This first module of the course, we're going to be talking about cognition, which is really a fancy schmancy word for thinking. And we're also going to be talking about how attachments or relationships are really important contexts for learning and development. The first reading that you're doing for this class, The Scientist in the Crib, focuses on how children think and how they learn, and on the research methods used to determine how children think and learn. So, I want to start out with some of the terms and clarify for you. You've probably come across the word structure in the reading. And structure refers to two different things. It refers to physical structures in the brain, such as neurons and synapses, but also it refers to conceptual structures, or what Piaget called schemas. Think of those as frameworks, ideas, or concepts. But cognition and learning also refer to processes, so the actual action of thinking. And the process of learning, you can think about it as the process of elaborating structures and processes. In other words, infants and children begin with rather simple structures and processes, and they add to those to make them more complex. Now, how learning happens and develops, we'll talk about that next and for the weeks to come. Everyone has a worldview about how children develop, regardless of whether you are an educator. Parents have worldviews about how children develop, and you probably have a worldview of your own about how children develop. So let's see how your worldview fits in with three main worldviews that are recognized in the field. The first one, an organismic worldview, really sees the child as being active and the environment as being passive. In other words, the environment or context the child is in just happens to be the place that they are. That children's development may be pre-programmed in a maturational point of view, or genetically programmed, as behavior geneticists believed. And actually even Piaget was an organismic theorist. He really believed that development was driven from within, and that the child was going to get what they needed from the environment because of their actions on the environment. So a child's going to learn about how balls roll because the child is acting on the ball, but that the environment itself was not active, it was passive. Now, an opposite worldview is a mechanistic worldview. Think about the metaphor of a machine, and think about the Industrial Revolution, the 1800s and the 1900s. At least up until the last couple decades of the 1900s, that the machine is really the metaphor for development. So the environment is active and the child is passive. They're being acted upon by the environment. Some people might conceptualize the child as being passive, like a ball of clay. They can be shaped by their environment and molded by their environment. Watson's idea that you could take any child and make them into a scientist, a beggar, a thief, an author, that sort of thing, is a mechanistic viewpoint. Some people say children are a product of their environment. That's a mechanistic and strict environmental view because it minimizes the active contributions that a child makes to their own development. Behaviorism is a mechanistic viewpoint because the idea that reinforcers or punishers have the same effect for all children means that it really isn't paying attention to the fact that children interpret things differently. So where one child might be humiliated by sitting in front of the class or being in a timeout, another child might find that really quite amusing. And so from a strict environmental standpoint, just keep in mind that a mechanistic worldview means that the environment is active and the child is passive. The assumption is that all children are going to respond the same way to environmental inputs and stimuli and situations. Now, a third worldview, the contextual worldview, sees both the child and the environment as active participants in development. But it's not just this plus that. It's not just what the child brings plus what the environment brings. There's a very specific matching of children's proclivities, what they bring, and with environmental affordances. So in infancy, for example, a child brings a preference for human voices and for human faces. And, not coincidentally, they come in contact with human voices and human faces, and they respond differently to human voices and faces than they do to other parts of their world. And so it's a fitting together. The contextual worldview, which is sometimes referred to as developmental systems theory, or Bronfenbrenner's ecological systems theory, really views this interactional process that both the child and the environment are active contributors to development. Now think about for yourself, which one of these worldviews best fits the way that you look at the role of child and the role of environment in development. The scientist in the crib takes a contextual view of cognitive development, and this is a different sort of nativism, a nativism that really recognizes both the importance of the infant and the context to development. Now think about the fact that there really are infinite possibilities about how infants could make sense of the world. But the vast majority of infants develop the same understandings about the world. They know that if they crawl under the table and stand up, that they're going to bump their heads. They understand how to move through space. They all develop language and communication skills. How does that happen? Well, there are constraints that are both biological and environmental, and those constraints eliminate some extraneous possibilities. Constraints we oftentimes think of as being limiting, but sometimes limiting extraneous possibilities, paths that aren't the best paths, actually speed up development. So think about it this way. You're in Lincoln and you want to go to the State Fair, which is now in Grand Island. Are you going to go through South Sioux City to get there? Are you going to go through Kansas City to get there? There are a couple of routes that are much more efficient that'll get you there faster so that you can spend more time enjoying the State Fair. Think of constraints that way, the elimination of possibilities that wouldn't be very helpful to begin with. So how are the child and the environment active? First, there are biological constraints. This is really important because if you think about it in terms of computerese, infants are born with an open program, or what some people call an ecological brain. Structures like synaptic patterns are not predetermined. So how is it that all typically developing members of the species develop in approximately the same way? Here, the concept of biological constraints can help us understand, and an example of that would be the orienting response, which is the infant's innate tendency to pay attention to novel stimulus in the environment. In other words, what's new and interesting, they pay attention to more than what they already know. And if you think about it, that's how you learn best too. If you keep reading the same notes over and over again, or if you keep listening to the same things over and over again, you're not going to learn something new. If you play a musical instrument and you play the parts of the songs that you know, you're not going to learn the parts that you don't know. You may have a tendency to want to play the parts that you know well because it sounds better, but you really have to force yourself to play the parts you don't know, or you're not going to learn the song. For infants, they have a preference or an orientation towards what is new and novel and different, and that ensures that they learn rapidly, and it also helps us to understand what infants see as novel and new, so that if you're presenting them with one Mickey Mouse doll after another, and then you change something about that, they'll notice that there's something different. These things are sometimes called first principles, what the child comes with in terms of their capacities. I mentioned an open program, but an open program is not the same as a blank slate or tabula rasa. They come with some pretty powerful abilities. And from the book, they talk about children's proclivities in terms of innate knowledge, which is powerful learning abilities. So the fact that they engage in multimodal perception and processing. Multimodal means through your eyes, through your ears, your nose, your mouth, your skin. And this is absolutely fascinating, that if you put an infant in front of a screen and you have their hands under a tray and you put a picture of a ball on the screen, and they will touch the ball under the tray, given a choice of toys. Then you change the picture and you put the block on the screen and they'll touch the block. What that means is that they're processing information in a multimodal way. In other words, what I see corresponds to or correlates with what I touch. I know that a ball feels different than a block does. And that is a first principle, or one of these proclivities that really speeds along learning. They also have representational capacity. In the olden days, not so very long ago, some people thought that infants couldn't think or represent in their minds what their experiences were, or couldn't remember things very well. We now understand that that's not true. They can represent and they can remember, and they can do so over a period of weeks, even when they're very young, that they can do that. And there are environmental constraints. In terms of sensory inputs, virtually all infants experience three-dimensional objects in space, a specific spectrum of light and sound waves, and so although environments are different in a whole variety of ways, cultural, climate, and so forth, that in terms of the physical environment, infants are experiencing pretty much the same laws of physics, and this is one of the reasons why they are able to learn in pretty much the same way around the world. All infants, typically developing infants, also have relationships. Now those relationships vary in quality, and with just a very few exceptions of severe deprivation, that relationships are a key component of infants' environments. The adults that they spend their time with, and the authors of The Scientist in the Crib refer to it as the unconscious tuition from adults. In other words, the adults are very invested in the well-being of infants. And so as a constraint, again, we think about this as being limiting, but the fact that there are more competent adults around children who are invested in their well-being means that there's a really good chance that those adults are going to provide for them what they need. So how do we know what they know? We have something that Piaget and Vygotsky did not have, and that is a different technology for studying infants and children. Piaget and Vygotsky were great observers of children, and they documented development beautifully. But one thing we have that they did not have is a habituation paradigm. Remember that a minute ago we were talking about how the orienting response means that infants are going to pay much closer attention to what is not familiar. This helps to ensure that they're going to continue learning new things and not just continue to rehearse and represent old things that they already know. So, what a creative cognitive scientist can do is create scenarios to determine what infants expect and what they don't expect. And cognitive scientists have a lot of fun designing their methodology. So, for example, if the cognitive scientist sets up a situation in which a ball is rolling down a ramp, and they have the infant watch the ball roll down the ramp for a few moments, and then they make it look like the ball rolls up the ramp, which a creative cognitive scientist can do, suddenly the infant is paying much closer attention. Their gaze, their heart rate, their respirations tell us that they're paying closer attention than they were when the ball was rolling down the ramp. What does this tell us? Well, we make the inference that the infant is surprised, and in order to be surprised, it has to be violating what the infant's expectation is, which means that they have a representation, that is, the ball is supposed to roll down the ramp. So this is one of the tools that cognitive scientists can use to determine what children know and what they don't know, or what they expect and what they don't expect. Another tool or understanding that cognitive scientists have is that not all stimuli are created equal. In other words, things in the environment have differential interest for infants, and they have some preferred stimuli. I mentioned earlier that infants prefer human faces and biological movement, human voices. One way that we can know what children prefer, and this has to do with our research methods and technology, is that infants will suck longer on a nipple to make an image they prefer appear or stay on a screen longer. And so this is a tool that we have at our disposal to be able to understand what kinds of things infants prefer. So what are some of these first principles that infants come with? maybe they understand the secrets of the universe, or maybe you can think about look who's talking. But when it gets right down to it, what is it that infants know, or that we can confidently infer that they know? Elizabeth Spelke refers to this as common sense knowledge. So, for example, the object concept. Piaget believed that children didn't have the concept of object permanence until they were about 18 months old. And the criteria he used for determining that was successfully searching for an object. Now, think about for yourself. When you can't find your keys or your ID, does that mean you don't know it still exists? I hope not, depending on what time of night it is and what you've been doing, maybe. But carrying out a successful search requires more skill than just knowing that something still exists. It turns out that one of the reasons that infants don't carry out a successful search until they're about 18 months old has more to do with the maturation of the prefrontal cortex, or an area of the brain that's right behind your forehead, responsible for executive functions. And the prefrontal cortex helps infants to be able to link together action sequences, so what movements they have to execute in order to get the object, rather than just not knowing that it's there. Again, creative cognitive scientists, because they have fun devising ways to determine what infants know and don't know, were able to demonstrate that infants do have the idea that an object is permanent and is still there even if you can't see it. So one method to do that was to hang a toy in front of the baby and turn the light off before they could reach for it, and then use night vision goggles to observe that they do reach for it even when they can't see it. Another creative way to do that was to put the toy inside a plexiglass box. Now, that's a little bit like putting tape on a cat's paw, really. Can be frustrating for the infant, but what they found out was that the infant would reach over the box and start to put their hand in the box, but when the wrist touched the top of the box, they'd pull their hand away and wouldn't try again. That's kind of a mystery to cognitive scientists for a while, because clearly the infant could see the toy and knew it was in the box and wanted the toy, so why didn't they carry out the action? Well, when their wrist touched the top of the box, they weren't able to adapt the set of action sequences to be able to move their arm in a different angle to reach it in. You have to be able to represent in your mind those action sequences, and the prefrontal cortex wasn't mature enough. So here was evidence that infants clearly knew that there's an object there, and it's there whether they can see it or not. And that we can't really use successful search to determine that the toy, the keys, or the ID still exist. So, object knowledge, what some of those first principles are that objects are solid, they're continuous, they're rigid, and they don't move unless you do something to them. Now that seems pretty complex, but I'll explain how cognitive scientists were able to make these inferences. First of all, the constraint of solidity. If you put a block in front of an infant and then set a book on top of it, the infant expects the book to be at a particular angle. So imagine that you're setting a block on your desk and then you're putting a book on it so that it looks like a ramp that's angled towards you. You can't see the object because it's behind the book, but you know that the object is rigid because it's holding up the book. It's in the way. Cognitive scientists, again, can be very tricky and put the block there and then have the block fall through a hole. If the book goes flat, the infant is surprised because the object takes up space. It's rigid. It's solid. Objects don't just squish. When you walk through the environment, the floor doesn't fall apart. When you lean on a chair or when you use a couch for support, usually it doesn't fall apart. Certainly different objects have different principles, and some things work better as supports than others. If you try to hold yourself up with a dog, it might get up and walk away. But in general, if you're holding onto a wall or you're holding onto a chair or a couch, those things are solid and you can count on those things to be solid. The principle of no action at a distance. The ball doesn't roll unless you push the ball or kick the ball. Creative cognitive scientists can make it look like objects are moving without any force. infants dishabituate. They're surprised. That's not supposed to happen. If you violate science with babies, they dishabituate. It's not magical thinking. If you make it look like magic, they're going to be surprised. They don't understand that. So, to make the comparison, there's really some core principles. Intuitive knowledge that infants are born with, and then they elaborate on that. Now, does that mean that infants don't require some formal learning, experiences, disequilibrium, planned experiences to begin to challenge maybe some of their misconceptions? Not at all, because formal science knowledge really requires tutelage. It's sort of like number concepts as well. Infants understand basic concepts of number, but they're going to need a little bit of help to learn algebra. So, beginning with some of these core principles, think of it as implicit and intuitive knowledge. The process of learning is making that implicit and intuitive knowledge more explicit so that children can reflect on that and know what it is that they know, be able to explain what they know. I wanted to draw your attention to this quote from the scientist in the crib. The idea that infants and children gain knowledge in the same way that adults and scientists do, through a very gradual unfolding sequence of corrected errors, expanded ideas, and revised misconceptions as we approach more and more nearly to the truth, is revolutionary. This is really the way that cognitive scientists understand children's learning processes in contemporary society. Children used to be considered very different from adults in the way that they thought, and now what we're understanding is that children think very much like scientists. So the title of the book is no accident. Children are systematic. They're observing the world. They're eliminating possibilities. They're comparing their previous experience with their new experience, and they're building revised conceptualizations as a result of that.